Now see here, the wavelength of first member of Lyman series is 1216 angstrom. Calculate the wavelength of third member of Paston series. We know it in spectral lines, 1 upon lambda is equal to r into 1 upon n1 square minus 1 upon n2 square. If we are taking Lyman series, so n1 is equal to 1 and n2 is equal to, we can take 2. So 1 upon lambda is equal to r into 1 minus 1 upon 4. So 1 upon lambda is equal to r into 3 by 4. So here we can write 1 upon lambda is equal to r3 divided by 4. We can get the value of r. So r is equal to 4 upon 3 lambda. This is the value of the Rydberg constant in terms of the wavelength in the first member, wavelength of the Lyman light in the Lyman series, that is the first member of the Lyman series. So we can go for the third member of the Paston series. In the third member of the Paston series, in the Paston series we can write actually here 1 upon lambda is equal to r into 1 upon n1 square minus 1 upon n2 square. So n1 is equal to 3 and n2 is equal to 4, 5, 6, 7, like this we can put. But the third member is this, if I take n2 is equal to 6. So we can write 1 upon lambda dash is equal to, value of r already we have got, that is 4 upon 3 lambda into 1 upon 3 square minus 1 upon 6 square. So 1 upon lambda dash is equal to 4 upon 3 lambda into 1 upon 9 minus 1 upon 36. When you solve it, you will be getting 1 by 12. So we can write 1 upon lambda dash is equal to 4 upon 3 lambda into 1 upon 12. So that is 1 upon lambda dash is equal to 1 upon 9 lambda. In this case, we can write lambda dash is equal to 9 lambda. So 9 into 1216 angstrom, that you will be getting 10944 angstrom. So this is the wavelength of the photon in the third member of the Paston series.